Hello, math friends. We are on lesson 4.3 in your Go Math book for 8th grade, and we're talking today about graphing linear, non-proportional relationships using slope and y-intercept. So remember that if you need to pause or go back in this video, please do so. So the first thing we're going to talk about today with our linear, non-proportional relationships is how to use slope-intercept form to graph a line. Hopefully you are starting to become familiar with the slope-intercept form, but remember that it's y equals mx plus b, okay, and b is the y-intercept, and m is the slope. And then we have x and y, which are going to be our coordinates with the values that we give them. And then also remember that the y-intercept is the x is always 0, right? And the b is whatever the y-intercept is. So you can use this form to quickly graph a line by plotting this point, this y-intercept, and using the slope to find a second point. And then you can connect the lines and see which points they go through. So we're going to do an example together. So we're going to first graph y. Oh, sorry. I'm going to write graph. And then our formula or our equation is going to be y equals 2/3 x minus 1. Minus meaning this is going to be -1. So when you see the fraction, don't freak out. That's actually going to be helpful when we do our graph in this case. So our first step, step 1, well, we know that we are going to identify first the y-intercept. So it's our first step, identify y-intercept. And in this case, the y-intercept is, remember it's this b right here, and so our equation is -1, so the y-intercept is -1 in this equation. Okay, so then we're going to plot that point on a graph. So plot the point that contains the y-intercept. Which in this case, what would the coordinates be? Remember, we're using this formula. So our x is always 0 because we're looking for the y-intercept. So our x is 0, and our y, what's our y? -1. Okay, so that would be the first point that we plot. So I'm going to add a graph in yours so that you can see what we're doing. Yours doesn't have to be a perfect graph. You can just draw one in your notes. Okay, so we have we're going to graph our first point because that's step 1, and the point we're going to graph is 0 as our y-intercept, 0, -1. So that point is going to go right here. And remember, you want it to be as precise as you can, so I'm going to fix that. Okay. Okay, so our next step is going to be to graph our second point. So we've got one of the points that was really easy because we just used our y-intercept with 0 being the x. So step 2, we are going to find the second point. So we're going to use the slope, which is m, to find the second point. Okay, so our slope is, in this case, in this example, our slope, oops, I was thinking n, not our slope, m equals 2/3. And remember, I told you not to freak out about that fraction because when we're talking about slope, 2/3 equals rise over run. Remember that? So what we're going to do is we're going to start from the point that we just made. We're not starting from the origin. That's the biggest difference between a proportional and a non-proportional relationship, is it doesn't go through the origin. Okay, so we're going to start from our y-intercept, which is 0, -1, right? And we're going to use this rise over run. So we're going to count up 2 and right 3. Okay, that's our second step. So we're going to go over to our graph, and we're not starting at 0, 0. We're starting at the y-intercept, which is 0, -1, our first point. And we're going to go up 2 and right 3. And there's our second point. Okay, now our last step is to draw a line through the points. Okay, so using your ruler, which I don't have, but you do. Let's see if I can find a straight line. No, not right now. Okay, so you're gonna draw, oh wait, yes I can, hold on. No, I can't. I'll figure it out later. So now you're just gonna draw a straight line through our 2 points. And remember, this line goes on and on forever in both, oops, in both directions. And you want to be really precise, which I'm not being right now because I am not using a ruler. So you should be using a ruler. But that is approximately where our line is, because this goes up 2 and over 3 using our slope. Okay, not too hard, right? We've got this. Let's try another example. I'm going to switch over to another page. If you have room on your page, you stay there. Okay, so let's try graphing this one. Y equals 5 over 2, that's our m, x plus 3. Okay, so step 1, we're identifying our slope. Or sorry, no we're not. We're identifying our y-intercept. So our y-intercept is 3. So our coordinate is 0, 3. Okay. Then our step 2 is to use our slope, and our slope is m equals, I did it wrong. We're going to do negative, sorry. Negative 5, 2. So m equals negative 5 over 2. Okay, and so we're going to plot both of those points. So I'm going to get a graph. Oops. Okay, there's my graph. I'm going to plot my first point, which is the y-intercept, so 0, 3. Okay, there's my first point. That's my y-intercept. Now I'm going to plot my slope, which is negative 5 over 2. So I'm going to start at my point. I'm going to start at my y-intercept. I'm not starting at 0. And I'm going to count down 5 and right 2. So starting here, going 1, 2, 3, 4, 5. That puts me at negative 2. But then I need to go right 2. 1, 2. Okay. I also could have done the opposite. I could go up 5 and left 2. Let's do that also. So starting at my y-intercept, which is 0, 3, I'm going to go up 5. So if I go from 3 and up 5, that's going to be at 8. And then left 2, I'm going to go over negative 2. And that's my point. So I can do either one of those because I can choose which one I want to be negative. Okay, but remember, if they were both negative, they'd cancel out. So you either want to do up 5 or down 5 and right 2 or left 2. Okay, so now I can use my ruler that I have and I can plot all these points, pretending that's a very straight line. So if you only choose one of those, if you only decided to do, down 5, right 2, when you draw your line, it's going to pass through that anyway. And when you have a perfect graph with a perfect line, you can see all these possible solutions as it goes through, just like when you learned how to graph them. So our step 3 is to draw a line through the points. Oops, that's a funky G. It's okay. Funky G's are allowed in math. Okay, so we have our graphing using the using the slope intercept form. One thing I want you to write in your notes is that a line with a positive slope will rise from from left to right. I drew this on the board, but just so you have it in your notes, a line with a positive slope this graph is in the way. Move out of the way, graph. With a positive slope will rise from left to right and conversely, a line with a negative slope will rise or will fall from left to right. Okay, so let's say I have two graphs. I have this graph and I have this graph, and they're perfectly straight and proportional. Not really, we're just taking notes. No need for perfection right now. So we have our two graphs, and if I have a line that goes like this, is that negative or positive? Well, is it rising or is it falling? Remember, if it's positive, it'll rise because positive people rise. And if it's negative, it'll fall because negative people fall. So is this one that I did first, is that positive or negative? It's positive because it's rising. Positive. And then if it's negative, it's going to look like it's falling. So let's draw it like this. This one will be, no, it won't be proportional. And it's really not straight, but that's okay. You get the idea. This one's a negative. Okay. All right, next example. We're almost done. You're doing wonderfully. Our next example, we are going to be talking about analyzing a graph. Because what's the point of making graphs? Oops, what's the point of making a graph if you don't know how to analyze it and how to read it? So there's a lot of real world situations that can be represented by linear relationships. And we've been talking about a lot of those. You can look back in your notes. So you can use graphs of linear relationships to visualize situations and solve problems. So here's our example. We have a friend, his name is Ken, and Ken has a weekly goal of burning 240 calories. No, that's not hardly any calories. 2,400 calories by taking walks. We're going to use the equation y equals 300x plus 2,400 to represent the number of calories right? That's y. Ken has left to burn. I forgot to capitalize his name, but it's math. Has left to burn after X number of hours. Oops, not number. You don't need to write that. Just X hours of walking. Which burns 300 calories per hour. Okay, so there's our situation. We need to graph the equation. Y equals negative 300, remember because he's burning calories, plus 2,400. So you should already be thinking which way our graph is going to fall. Is it going to fall or is it going to rise? Well, it's negative, so it's going to fall, right? So it's going to go this way. Okay. Oops. So, step one. We're going to write the slope as a fraction. Remember I told you fractions are helpful in slope world? Well, this is not a fraction, so we're going to make it one. So we're going to write the slope as a fraction. Okay, so we have m equals, our slope equals negative 300 over 1, right? Because then that maintains the value, but now we have a fraction. Okay, so we also want to write a couple equivalent fractions. So I'm going to multiply this whole thing by 2. So what I'm going to multiply the top by 2 and the bottom by 2. So now I have negative 600 over 2. And then I want to find one more value because I will need some plots, some points to plot. So I'm going to multiply it by, or I'm going to multiply this by 3. So 300 times 3 is 900 over 3. Okay, so using the slope as negative 900 over 3 is going to help draw a more accurate graph because we can reduce that down. Okay, so now for my step 2, I'm going to plot the y-intercept. And what's the y-intercept? Well, I'm going to go to my equation. There it is, 2,400. So I need to write that as an ordered pair. So it's going to be 0, 2,400. Okay, so my second step, or sorry, that was my second step. My third step will be to use the slope. And I'm not graphing this right now, I'll graph it in a second. Let's just write the steps down. So use the slope to locate a second point. So I'm going to get my graph again. Actually, I'm going to draw my own graph because I don't have a graph that has 3,000 for my calories. So I'm going to make my own. We just need quadrant 1. On the bottom, we're going to have the time. So I'll have 2, 4, this is time in hours, 6, 8, 10, 12, and on and on. This is our time. And then on this side, it's going to be calories remaining. So I'm going to count by 600s because I want to get the most accurate graph I can. And so I want to start with a higher number because we have to get up to at least 2,400. So I'm going to start here with 600. And then I'm going to double, so 1,200. Add 600 more, makes it 1,800. 2,400. And 3,000. Okay, and these are my calories remaining. I can't write sideways. Calories remaining. Ah, my earbud fell, don't worry. Okay, so now we can graph. So we're going to first graph our y-intercept, which is 0, comma, 2,400. So it's going to be, I'll use a different color. So our first point is going to be right here. That's our y-intercept. And then we're going to start from there we're going to use this one, remember? So that was easier because it's on our graph. So we're going to do down 900 and right 3. So if I am starting at 0, 2,400, and I'm going down 900 and right 3, well, I'm going to be adding 3 here, and I'm going down, so I'm going to be subtracting 900 here. Okay, since we're dealing with such big numbers, that's why I'm figuring this out over here. So we know this is going to be a 3, right? Because we're using this 3 and this 900. Okay, and then we're going to subtract. So 0, 0. 14 minus 9 is 5, 1. And we're keeping it negative. No, we're not because we're going down. Okay, so our new point is 3,1,500. So I'm going rise over run. So over 3 from here. 1, 2, 3. And then down 900. And we figure that out. So it's going to be right about here. My last step is draw a line through the points that connect my dots. So now we have this information we have graphed. Now I want to be able to answer some questions about what I just did. So let's say we want to know after how many hours of walking, oops, I'm getting too close to my graph, of walking will Ken have, looks like Ren, will Ken have 600 calories left to burn? And I also want to know how many hours it's going to take to reach his weekly goal. Okay, so the first thing we're going to do is we're going to locate 600 hours on the y-axis, and we're going to read across and down to the x-axis. So we're finding our 600 is going to be right here. Okay, and we have 600 calories left to burn after 6 hours. So we're going to follow all the way to the 6. Okay, so Ken will reach his weekly goal when the number of calories left to burn is 0. So because every point on the y-axis has a value of 0, find the point where the line crosses the x-axis. Oops, y-axis has an x or a y value. And since my graph isn't accurate, it's actually not giving the right information. That's why it's important to have an accurate graph. So let me fix that a little bit. Because we have our correct point that we calculated, but we didn't quite connect it. Why are you not erasing? We didn't quite do that. Okay. So it's actually cross here at the 8. We're going to pretend it's a really straight line. This is a perfect graph. Okay. And we'll do an example of this together. So we know that Ken will reach his goal after 8 hours. Okay. Lesson learned. Really important to have accurate graphs. When you're back in the classroom, I'll have my stamp ready. All right, last thing we're going to do is the guided practice. So would you please get out your math book and go to page 112. All right, so we're on page 112 doing the guided practice. So it says graph each equation using the slope and the y-intercept. So we're going to first identify, using our steps that we wrote, we're going to first identify the slope, which is 1/2. Good job. And then what's our y-intercept? it is -3. And then that's the y, so the x is going to be 0. So our coordinate is going to be 0, -3. So that's going to be our starting point. So let's graph that. Really accurate graph. So we're going to first do the y-intercept. It's really important that you remember to do that first. So over 0, down 3, there's our point. And then our slope is 1/2. So not from 0, 0, but from our y-intercept, we're going to go rise over 1, run. So up 1/2. There's our point. Up 1/2. There's another point. We're just going to keep going until we can fall off the graph. 1/2. Now we're going to do the opposite starting at our 0, 0. This is going to make sure we have a really accurate graph, because the more points you plot, the more accurate your graph's going to be, especially when you don't have a ruler like me. So now we're going to go down 1/2, down 1/2, down 1/2. And then using your ruler, using my best, we're going to draw our line. Okay, and is this a positive or negative slope? It is positive. Okay, next one. We have y equals -3x plus 2. What's our slope? Well, it's -3. We're going to write it as a fraction, because remember, fractions are our friends when we're finding slope. So -3/1. And the y-intercept is 2. And to write that as a coordinate, it's going to be 0, 2. So what are we going to plot first? We're going to plot the slope, or are we going to plot the intercept? We're going to plot the intercept. That's right. So we're going to go up 0/2. Or sorry. Right here. Okay, so now from there, we're going to do our slope. So we're going to go down 3 and over 1. So starting here at 0, 2, we're going to go down 3, 1, 2, 3, and over 1. There's our point. We keep going. Down 3, over 1, down 3, and we're off the graph. Okay, and then the opposite of that is we can go up 3, 1, 2, 3, over 1. Okay, and this is a pretty steep slope. We're going to connect our dots. Oops, that's not super accurate. Okay, so there is our graph, and this one is starting high and it's falling, so this is negative. All right, number 3, a friend gives you 2 baseball cards for your birthday. Afterward, you start collecting them. You buy 4 cards each week. The equation y equals 4x plus 2 describes the number of cards you have after x weeks. So the first thing we're going to do is we're going to find and interpret the slope and the y-intercept of the line that represents this fraction. Graph y equals 4x plus 2 and include axis with labels. So I'm going to have you finish number 3 on your own. I'm going to have you finish number 4 on your own. And when you're in class on whatever day you're in class, either Tuesday or Wednesday, we're going to go over these 2, but I want you to have these done before. So you can either take a picture and send it to me, or I can check it in class. Also, when you come to class on Tuesday or Wednesday, please have any specific questions about this lesson that I can help you with. And then we're going to be working on PMT today when you're done with the lesson. So if you have specific questions, you can either bring them to class or you can email me with them. And I hope you have an awesome time interpreting your slope intercept formula, and I will see you soon. Bye-bye.